tangent functions. Okay, so today's date 4/23/25. Now I need you to remember in all the graphing, you have to have the amplitude and the period stated. Now, I think I'm going to make an exception for tangent for the domain and range, but for sine and cosine, for sure, you need to know domain and range. Okay? So I'm giving you that heads up right now. You have to be able to state the domain and range for sine and cosine, but not for tangent, and you'll see why. All right, here we go. Tangent function is one of the trigonometric function whose graph has asymptotes. I've talked to you guys about asymptotes before, yes? Where it's undefined when you take the tangent of an angle, yes? Put that ball away. Okay, so let's look at tangent. Okay, tangent is going to be y over x. Agreed? Okay, tangent function is y over x using whatever points we have, whatever ordered pairs we have, we take opposite over hypotenuse. Agreed? Okay, from there, let's start with where the undefined parts are. Where are the undefined values? Do you remember? Right off the top of your head? No? Y-axis, right? Because if I put 1 over 0, what do I get? Undefined value. You cannot get any real numbers by dividing 1 by 0, right? So if you can't get any value there, then that means there is an asymptote, okay? So pi over 2 has an asymptote. I'm going to do it in pink. Okay. Should that be a solid line? No, it's an invisible wall that you cannot cross as a graph, okay? Where else would that be? Negative pi over 2, okay? So it's wherever we hit the y-axis, yes? Every time we hit the y-axis, we are going to have an undefined value. Okay? So when else would I hit the y-axis? 3 pi over 2. So I want you to graph in all of the asymptotes before you even start graphing the tangent line, okay? It's going to help you tremendously, okay? And then the other way, if I were to go in the opposite direction, so if this is negative pi over 2, this will be negative pi, this will be negative 3 pi over 2, okay? So that will be where a normal 90 degrees would be, but that would be negative 270 degrees. Are we okay? That's all I can fit on the graph, so that's all I'm going to graph, okay? And you're going to be given the exact same grade on the test and in your study guide. Are you okay? Now, what's my tangent at 0? Pi. 0 pi. What's my tangent there? 0 over 1. Oops, I should use purple. 0 over 1, which equals 2. So I'm going to make a small table here with in and out. In is my x value, out is my y value, right? On this graph. On this tangent graph, I'm looking at in for 0 pi, right? Then I get 0 out when I do tangent of that 0 pi, yes? So that's going to be at the origin right there. Yes. Okay. Are we okay so far? Tangent is opposite over adjacent. So it's y over x, sine over cosine. Okay. So when we see the ordered pair from 0 pi, you look at the x and y, put y over x. Okay? So, and then what's my next one? Let's see. This is cosine and this is sine. So you put sine over cosine for tangent. Does that make sense? Okay. cosine is x because it reads the adjacent side of any angle, okay? All right, I want you to look at this as a whole. Don't look at it like to the unit circle too much because I don't want to confuse you, but it comes from the unit circle. You have to understand that, okay? If I take halfway between 0 and pi half, where is it? Pi over 4, which is 45 degrees, right? Half of 90 is 45 degrees. Take pi over 2 divided by pi over 2. They're identical in numerator and denominator. What do you get? 1. This is pi over 4. It goes to 1. Okay? And you're going to make half of an upward parabola. Half of an upward parabola like this. And you're going to get really, really, really close to that asymptote, but you are never going to cross it. Are you okay so far? Okay. We're going to go opposite direction for the negative. Okay? Where's the halfway between 0 and negative 90? Negative pi over 4, which is at right here, right? So that's negative pi over 2. Negative square root of 2 over 2 divided by square root of 2 over 2. Putting this above that. Yeah? And that would equal to negative 1. So I'm going to go to the left one and go down 1. Does that make sense?
Yeah.
No? How do I know which one to use? I'm looking for halfway point, right? Halfway point from 0 to 90 is 1/4, right? Which is 45 degrees.
Do you do that with all of them?
Yeah. You're going to be doing that for all of them for tangent, okay? And I'm going to explain more when the amplitude changes and when the period changes and so forth. That's the upside down parabola, but it's going to go downward, okay? It's because it's upside down. So right side up on the right side, left side down, okay? Are we okay so far? Yes? And you repeat. So go to the next period. This is one period right here. This is one period. We're going to go to the next period. Where's the center? Pi. Put the x-intercept there. You're going to go halfway between the asymptote and pi. Where is that? That's 1/4 of the way, right? So I'm going to go up 1 and make my right side up parabola. That's terrible. Let me try again. That's better. And then on the left one, halfway between the center and the asymptote, that's 1 unit over, right? On the graph, but it's 1/4 of a pi. Go down 1. How are we doing? Good. Upside down parabola, just the left half. How are we doing? Yes. Rinse and repeat. Rinse and repeat. So let's go to the left, the negative side, right here, between these two parabolas, okay? Where's the center? Negative pi. So you're going to place your point right there in the center, okay? Then you're going to figure out where's my halfway between my center and the asymptote. Center and asymptote, halfway, right here, right? 1/4. 1/4 to the right, 2/4 to the right gets me to the half of a period, right? So I go up 1. Okay? And then we're going to do it again. Go to the left, asymptote, and the center. Where's halfway there? And then go down 1. Now, you can't finish graphing both directions on these ends, but you still have to graph because these don't stop at these intervals. Okay? You're going to continue doing that. So where would the midpoint be if I were to graph another asymptote? If I had another asymptote, it would be 1, 2, I'm counting this way, let me show you. From the center here, right? this is 1 period. So that's 1, 2, 3, 4 units for every asymptote, right? So from here, it'd be 1, 2, 3, 4 here, right? If I were to graph an extension to that, I would have an asymptote like off the grid here, right? Does that make sense? Then where would my center be? 2 pi. Okay, 2 pi would be there. And then the halfway between 2 pi and the right side asymptote will be still on the computer over there. Right 1, up 1, right? There you go. And then to the left 1, down 1. There you go. So I don't need all of this because my grid does not give me any more than that, right? But you can't stop it there. You have to extend it continuously that way. Do you see why I couldn't finish it? Because the grid stopped, but it goes on and on forever, right? Okay. All right, let's go to the left side in the negative world, okay? Asymptote will be 1 more unit away from here at the end of my grid. The middle would be, the center would be negative 2 pi. We're going to go to the right 1, up 1 because that's my halfway point, and up exactly that amplitude. There's my positive side. There's my negative side. It would keep going. You don't have to graph it. I just need to stop it like maybe about here. And I don't need all these asymptotes anymore. Okay, so there it is. What do you think? It's not as bad as you thought it would be, right? Okay, so amplitude was 1. Period is a whole pi. Yes, Remy.
So like I don't know if it like changes, I guess, but like in this case where there is like a pattern, like in those cases if you can identify like the pattern, you can just like go over that. Like if for example just like the whole pies.
Can you rephrase that one more time? Because I kind of got lost when you...
So like because the pattern is like is like a period for like the whole pie, you can identify the period and you can just like go.
Yeah. Yeah. For this one, for tangent, the normal period is a whole pi, like this. Okay? Between the asymptotes is 1 period. That's what one part gets repeated over and over again, right? So 1 period gives you the whole cycle, right? And it just happens to be 1 pi because the center is here, and we have a little bit to the left and a little bit to the right between these asymptotes where you cannot move on anymore, right? Okay, so let's try this. Okay, x and y values of the ordered pairs from the unit circle are going to be primarily used for our tangent. Okay, so it's gonna be, what do we do to figure out the tangent values? Opposite over adjacent. Opposite is the sine part, and adjacent is the cosine part, right? So it's gonna be y value over the x value. So if I put y value over the x value for 0 pi, what would that be? 0 over 1. Do you see where I got those numbers? Okay. So what's 0 over 1? 0. So I'm going to go ahead and plot it right there. Okay. If I go to 90 degrees, which is pi over 2, what happens with my tangent there? Tangent of pi over 2 equals 1 over 0. Is that something I can have as a real number? No, it's undefined, right? It's undefined. Therefore, we are going to have what? It means you're going to have, yep. So at pi over 2, it's going to be an asymptote. Okay? If I keep going to 180, what's my tangent value there? This is my x, this is my y. 0 over, sorry, that was way too close. It looks like an 8. 0 over -1, which is 0. So I'm over here. Here's my 0. Right? And then, what is it for this one? What's the tangent there? Tangent of 3 pi over 2. -1 over 0, which would be undefined again, which means I have asymptotes again. Do you think you might see a pattern here? How do you go past the asymptote? It's a cycle, right? So it repeats the same pattern over and over again. It's not going to cross, but you're going to have a repeat of the same thing, okay? So what if we went the other way? What if we went this direction for negative pi over 2? What will my order pair be? Isn't it this? So wouldn't I have another asymptote there? And then I do it again. I continue going this direction. Here. What's my tangent there? 0 over 1, -1. So that will be 0. And then I go again to this direction. That will be 3 pi over 2, right? 3 halves. This will be 3 halves. Then I would have another asymptote. Huh. Pretty interesting how they keep repeating, right?
Yeah, that makes sense.
Okay. What is the halfway between 0 and half pi? Quarter pi. Quarter pi is this one, right? So it's that. Okay? Don't overthink it. I need you to simplify the whole thing that I'm saying, okay? This is y over x. They're identical. If I put this over the square root of 2 over 2, I'm going to yield 1. Does that make sense? So tangent of 45 degrees is 1. So I'm going to write it out, but don't panic. Tangent of pi over 4 is equal to square root of 2 over 2 divided by square root of 2 over 2. Don't panic. This is same thing as this, so it's going to be 1. Does that make sense? Okay. First period panic because I didn't explain it that way. All right. So I'm going to go quarter of the way, and I have to go to 1. Okay? That provides my curve, right half of my tangent curve. Okay? So let's go the opposite direction. Where's my quarter of the way here? It's -1. And that's the second half. This is your tangent single period graph. This is going to repeat between every asymptote. Every set of asymptotes that you get, it's going to be repeated over and over and over again forever and ever. Yes?
So like the one on the right and the one on the left is going to go the same way?
Yes. So we're going to go to the right 1 and up 1, just the same way I did with the main one in the center. And that's another 1. Left 1, down 1, and here we go. Okay? I can do another one to the left of that main one. right one, up one, curve. It's half of a parabola, okay? It's not just a squiggly line that's going up. It's half of a parabola. Veronica, what are you looking at on the lap? The other hand and phone? What's on your lap? Okay. All right. Left one, down one, down. All right. It's going to continue forever now. It's not going to stop. Tangent ones are always cyclical, and it's going to keep going forever and ever in both directions. Domain, unlimited, except for the asymptotes. That's the part that's really hard for you to write, so I'm nixing it, okay? I'm not making you do it. This side, if I were to show you the center, but I won't be able to show you half of it, right? Because it cuts off on the 3/4 part. It doesn't have 4/4 like it's supposed to for a period. It only shows 1, 2, 3/4, right? So I'm gonna put in my center point. Okay, so I'll do my center point here on the right. And then I'm gonna go to the left one, down one for my second point. And then to the right one, up one. And my asymptote, if I were to graph it, if I were to extend my graph, I would end up having one more unit here with the asymptote, right? But we can't graph that. It's not there. So what you're going to do is you're going to just do that for the right side. And then on the left side, you could extend it further. So you really wouldn't have this. Does that make sense? Why we're not doing that? Okay. Left side. Here's my center. I'm going to go to the right one. Am I going up or down? Up. The right side is going up. Left side is going down. So I'm going to go to the left one, down one. And it should make a U shape and continue going down that way. Okay? How you doing? Okay. Amplitude is where my high points are and the low points are, right? But tangents don't have that. It goes in infinite directions in both directions, right? So the only way that the amplitude is counted is by going halfway between the center and the asymptote. And on that x value, you're going to go up as high as the amplitude reaches. So if it wasn't a 1, this one says 1 times tangent of theta. If amplitude was a 1 and it said 3, you would go halfway between the middle, the center, and the asymptote and go up 3 and plot your point there. And your curve would go through that point and continue forever. Okay? So amplitude is slightly used differently in tangent because they don't have a peak. Does that make sense? Yes. All right, 1 for amplitude. The period is the distance from one side of the asymptote to the other. How long is this period? That's 4/4. It's pi. Because it's half from the center to the left and center to the right. So what's half plus half? 1 whole, right? 2 halves is 1 whole, yes? All right, so given y equals a times tangent of b theta, where theta is in radians, the period is pi divided by b in absolute value. Okay? And the asymptotes are, okay, this is the tricky part. Asymptotes are, don't freak out when I write this, okay? I'm going to try to explain best I can without explaining sequence. Odd multiples of, don't freak out, okay? Pi over 2b. Pi over 2 times absolute value of b. Okay, do not panic, okay? This is what it means. Do not panic, okay? Try this. What's the amplitude? What's the amplitude? 2. Amplitude is not asymptote. Amplitude is not the asymptote, okay? What's my period? Pi divided by b. What's my b? 1. So what's pi divided by 1? Pi. So the length between the asymptotes is going to be a full pi. That means the center is going to be half of pi, right? So if amplitude is 2, we'll use that later. Don't worry about this. The center is still going to be the same. Okay, center is still here. If I want to make a full period, I need to make it evenly broken up from that center. So how much should I go to the right to make my asymptote? Do I go a full pi or do I go half of that pi? Does that make sense? So I'm going half of that pi because I need to make a full pi using both sides of my center. My center is on the y-axis right here, right? So in order for me to make a full pi from asymptote to asymptote, I need half of it on the right of the center and half of it on the left of the center. Make sense? Okay. And then the amplitude is where we get to use halfway between the center and the asymptote. Right here in the middle at 1/4, we're going to go up 2. 1, 2. So I'm plotting my point halfway between the center and the asymptote. I'm going to go up 1, 2, just like the amplitude says. It's a half parabola. It is not a squiggly line going to that, okay? It's just a half parabola sweeping up, okay? Then we're going to go to the left between the asymptote on the left and the center. Halfway in between would be -1/4. I'm going to go down 2. Okay? And then make an upside down U from there. How you doing? You okay? We're going to repeat this picture every pi. Okay? So how many units does it take on this graph to make a full pi? 4. So I'm going to count 1, 2, 3, 4, and that's where I lay my next asymptote. Does that make sense? Okay. I'm going to do it again. 1, 2, 3, and then 4 will be off the grid, right? But that would be where it goes. If you want to graph it in, that's fine, but you don't need to. I'm going to do it for the sake of your vision for this, okay? Let's go the opposite way. We go the same 4 units from this last asymptote on the left. 1, 2, 3, 4. There's your next asymptote. It matches, right? It should match. Okay, and if you go again 1, 2, 3, 4, I should have another asymptote there if my graph coordinate plane would extend that far. Where's my center for, let's go to the right of the middle, the main period here, to the right. Where's my center between these two? Pi. So I'm gonna graph that center and then find the halfway between the center and the right asymptote. There's a lot of talking going on that doesn't involve vocal talking. Center to the asymptote, right asymptote. Where's the middle? It would be literally just look for the half point right here. Okay? And then we're going to go up 2. Graph the U. And then go to the left 1, down 2. And here we go. What do you think? Not too bad, right? Do you think it's easier than sine and cosine maybe? Just because there's like breaking points, right? You just have to continue doing that for each one. 2 down. Okay, and then on the left side, middle, half of it, go up 2. And then left 1, down 2. There we go. And then here, half would be here. And then 2 down. Okay. Questions? Okay? Too easy? Ready for the next one? Let's change the period. Because, you know, we can. By the way, these are not transformations. These are not transformation. You're basically graphing a bunch of parent graphs. Okay? So y equals tangent of 1/3 theta. Okay? Amplitude is what? 1. Because the coefficient to this tangent function is not there, it's always a invisible 1. Okay? Period, however, is going to be pi divided by 1/3. I'm going to say it again. Pi divided by 1/3. What do you do when you divide a fraction like that? Keep, change, flip. Keep, change, flip. And you have pi times 3 over 1. So what is it? 3 pi. All right, you ready? I'm going to show you on the screen because it's going to be hard to show on one dotted parts. This is a normal 1 period, right? Okay. If I were to add another period, I would go another half over on both sides. Agreed? So if I go 1/2, another half, I would have, what's the period then? 2 periods, right? Sorry, 2 pi's, or 1 period. Are we getting this? Okay. 3 would be another half on both sides. What does it say there? Oh, 3 pi over 2. Does that make sense now? It does. It kind of click a little. Okay, let's do the center. The center is still 0, 0. Okay. Now, this is the tricky part. You ready? What's the halfway point between the center and the right asymptote? Right here. 1, 2, 3 units away, 3/4. Right? Every 3/4 is going to be my halfway point. How high should I reach based on this amplitude? 1. So I'm going to go to the right 3 units, which is 3/4, and go up 1. 1, 2, 3, down 1, and rinse and repeat. On the right side, I don't have 3 periods, a grid left, right? I only have 1, 2, 3. So I can only show a 4th. I can only show this part right here. Does that make sense? So I'm not showing all of the graph, but I can show this point and the way it's going down, and maybe a little tidbit of which way it's going up. Does that make sense? So we're going to do that right here. Yeah. I am. Remind me to post it if I forget. So I'm putting my point there. I'm going downward, and it's going to continue going that direction, crossing 3 more units over into the center at the X intersection, right? All right. Bye, guys.
Bye, guys.
And then on the left side of the left asymptote, I'm not going to see all of this. I'm going to see 1/4 between these 2 asymptotes, right? I'm going to see this part. So I'm going to take this picture, repeat. Okay?
So how is you?
Like this. Right? Yeah. Ava? Yeah. You do. I'm sorry? Yeah. Because the function does not end here. Function continues on forever, so you have to show that they do continue even beyond the center step, a period. Okay? All right, are you good? All right, let's try this one. Amplitude. What's the amplitude here? Half. Is this going to be really wide, or do you think it's going to be really narrow? Amplitude is half. That means if the center's here, I'm going to go only halfway up for my next one, wherever it may be. Is it going to be a very narrow one, or is it going to be a wide one like that one? Narrow. Okay, let's see. Period is going to be pi divided by 2. Pi divided by 2 is a larger period or a smaller period? Smaller than its original. So I want pi over 2 to be a full period. So it would be 1/4 on both sides. Right? Does that make sense? Okay. So we have 1/4 on the right, 1/4 on the left of the center. Okay? What I would recommend is that you graph all of the asymptotes first before you start graphing the center pieces. Okay? So I'm going to go 1, 2, and then 1, 2, graph. All right. Where is the center? Between wrong one. This one and this one. Between those two asymptotes, where's the center? 0, 0. Here it is. The amplitude is half, but how far do I go to the right to get to my halfway point? Half of this space, right? So that would be 1/8. 1/8. Okay, bless you. Go up 1. Oh, sorry, that's 1. I need to go up half, so it should be in the middle of the box. Does that make sense? Well, I'm going into the middle of the box, Joey. Why? Because it's half to the right and halfway up, right? Okay. I'm going to go to the left half and go down half. And rinse and repeat. Okay? All right, I need all of my positive side.
Wait, Miss Ben, do you record like all 3 classes?
I did ask for quite a lot of storage room on this, though. Yeah. I got it as a TPSF grant. So I can record it and give you guys the lessons like this.
Do you take it home?
I do take it home to finish loading it on YouTube. Black. You know, when I'm giving you the time, you should graph it. I could have easily just done copy and paste, but I did it with you guys. Hopefully you did it too. Here we go. Amplitude is 4, period should be 2 pi. Here's the asymptote. Asymptote should be at every pi from the center. So here's the center. I'm going to have to hit pi. And then another pi. And that makes a total of 2 pi between the asymptotes. Does that make sense? Yes? No? Yes. All right. And then halfway between those two would be at half pi. So I'm going to go up 4. So it's a pretty steep one. And down 4. All right. There you go. That's the center one. Rinse and repeat. gonna give you guys 5 minutes to pick any 2 questions on the next page. 5 minutes for any 2 questions on the next page.
Can you reteach cosine, please?
Absolutely.
Wait, actually?
Yeah.
This thing over here.
Huh?
Oh, sorry. Can you go back to the other one? So on this one right here, why isn't it like coming to this line right here? Like,
It can, but it's just like it's going to go up 4 every time I go over. It's gonna be going up 2 every time I go to that house.
Oh, but it,
Right?
So eventually it will.
So
touch
it
that.
will get really, really close way
It
down
won't
there.
touch it. Okay.
Yeah. It won't
But
cross.
so if I were to like graph it on like really close, would that be wrong or you didn't care?
It shouldn't go towards it, but it should be close to it.
So but if it's like
So don't make an extra wave like this to get there.
no, but if it's like if it's just like this, that'd be okay.
Well, as long as you hit 4, negative 4 at negative half,
Oh, okay.
right?
Alright, thank you.
Yeah, I'm gonna go over sine and cosine. Okay, what's the amplitude for number 2? I'm doing sine review. Sine review. Okay, sine review. If you want to go without me, go ahead and go and do 2 questions right here for yourself. It's 1, and then period is not the same way that we would split up our period. It's 2 pi divided by 4, which is pi over 2. Okay, now that you have a better understanding of what a period is, right? I want up to half pi to reach the full cycle of a sine. So it needs to go up, then down, and up. That will be a full cycle for sine. So I'm going to zoom in real tight. And I'm going to start at 0, 0. It's going to go up to 1 at its highest point, middle, lowest, and then middle, right? So it's going to continue going up, down, up. It's going to repeat. 1, 2, x-intercepts, 1 up, the other down. Up, down, up. That was more of a V. Hold on. Up, down, up. Does that make sense? And you just keep repeating. Every period, every half period you reach, you should have a full cycle of a sine. Okay? So here's another one, up and down in halfway points and down. Is that easier now? Now that you understand period and its high and low cycles, biomatics, good luck. Okay, are you good? I know this is what happens when athletes are in my class. Yeah, what's up?
I don't know how to do sine.
I'm doing it right now.
No, I don't understand it.
The cycle is up, down in an S shape, yeah?
The period for sine.
It's 2 pi divided by b, absolute value of b. Okay? Are you good? Okay, next one. I'm only going to be able to show half of sine. So I'm going to go up and keep an arrow out, like this. Okay? And then rinse and repeat to the negative. Are we going to start at down or up? Down. So here's my half. And then my full period. And then I'm going to go down halfway between the first 2 points, halfway up between the last 2 points, down and up. And repeat. Here we go. And then right here, we're going to do x-intercept, down, then up. Down and up. Okay? And green, purple. 1, 2. Down, halfway, up, halfway. Okay? And then pink. 1, 2. I'm going to go down, then up. You want me to do it for sine too? And down.
Or just 3.
Just 3? All right. So what's my domain here?
Or do we have to do domain?
Yeah, you need to do domain and range for sine and cosine. Negative infinity to positive infinity. Range is brackets, -1 to +1.
Wait, Miss Bian,
Yeah.
you don't have to do this with test, right?
Yeah, you do. That's why I'm doing it right now. Sine and cosine, you must do domain and range. I could add it to tangent just to keep it consistent, but I thought I'd save you the trouble right now.
Wait, on this test, do we need to do it throughout the whole thing?
You have to do the whole.
It's good so you know it. Dude, I'm gonna take trig.
Cosine. All right, I'm going over cosine. You ready? It's not an S shape. It's going to be like a bowl shape. Okay? It's going to be like this, right? Like a C, like a stretched out C. So amplitude is half. Period is going to be 2 pi divided by 2. What's 2 pi divided by 2? 1 pi. So between 0, where we start halfway up, let me do it in red. My full period is going to end at 1 pi. Okay? So it's going to end up here. Halfway up, just like the amplitude. And the lowest point is going to reach half from the x-axis, right at the midpoint between those two. This is the midpoint. I'm going to go down half.
Wait, Miss Bian,
Okay? Yeah.
how come like you went up half and this is half?
Because the amplitude is half. But the cosine is up, down, up, right? So I'm doing that pattern, up, down, up. And then halfway between the middle and the beginning, right here, is going to be where my x-intercept's going to be.
How come for sine you don't start?
Because sine starts at 0, 0 and goes up then down. That's why I said S is important, right? So I highlighted the S at the lesson and then C for cosine. Yeah, those are the repeating pictures. All right. So I'm going to curve. There's my weird bowl of a C. Okay? Do you see my sideways, upside down, or sideways C? See? See it? See? Haha. All right. So a full pi would make it here on 2 pi. Halfway between those two will be 3 pi over 2. Then halfway between the half and the first point will be right here where the x-intercepts are. Do you see my U shape? Just curve it. Don't make it a V. Make sure it looks like a U. Okay? So next one's going to be just to the x-intercept, and it's going to continue. Yeah. No, because tangent is different, where the center is no longer here, it's in the middle on the y-axis.
It's only for tangent.
Yeah.
And the other two are just like this.
Yes. So I'm going to go to negative pi, half pi, mid. Okay. Next one. 2 pi, negative 2 pi is going to be my amplitude's height. And then the valley will be at negative 3 pi halves. X-intercepts in between. And go. Okay. And last one's gonna end down like this. I did it in different colors on purpose for you. You do not have to do it in different colors on the test. Okay? I'm just doing it in different colors so you can see each period very clearly. Okay? So I can fit 1, 2, 3, 4 full cycles of the same period. Does that make sense? Okay.